Ever wonder how websites handle thousands of users at once?
Uh-huh.
Or how your phone can run multiple apps without
Yeah.
breaking a sweat?
Yeah.
You're about to find out.
Mm-hmm.
We're doing a deep dive into the world of Java concurrency,
Okay.
where your computer juggles multiple tasks concurrently.
Right.
We're about to unlock the secrets of 10 powerful features that make modern Java a master of concurrency.
Okay.
And don't worry,
Mm-hmm.
you don't need to be a coding whiz to follow along.
Okay.
Expert speakers here to break it all down,
Yeah.
and by the end of this, you'll be throwing around terms like thread pools and parallel streams like a pro.
What's fascinating about concurrency is that it's everywhere in our tech.
Um,
But most people don't realize it's the reason their favorite apps and websites are so responsive.
okay,
Yeah.
let's unpack this.
Sure.
What exactly is concurrency in Java?
Imagine a busy coffee shop.
Okay.
In the pre-concurrency world,
Mm.
there was only one barista. Every order had to be made one at a time espresso, then steaming milk, then that complicated latte art. Right.
So a very slow-moving line and some very impatient customers.
Frankly.
Yeah.
But with concurrency, it's like suddenly having a whole team of baristas working in parallel.
Wow.
One's grinding beans, another's steaming milk, another's mastering latte art.
Okay.
Orders get completed faster,
Yeah.
customers are happy, and the coffee shop thrives.
So concurrency in Java is about writing code that lets programs perform multiple tasks seemingly at the same time,
Yes.
making them super efficient.
Precisely. And to manage this complex dance of multiple tasks, you need the right tools.
Okay.
That's where these 10 Java features come in, each one a specialized tool
Yeah.
designed to tackle a different aspect of concurrency.
All right, let's dive into our first tool, the fork join framework.
Think of a huge jigsaw puzzle,
Good.
the kind that takes over your entire dining room table.
All right.
Instead of tackling it piece by piece, imagine being able to magically split the puzzle into smaller sections,
Okay.
each handled by a different person
Yeah.
simultaneously.
So instead of one person spending days or weeks on a massive puzzle,
Right.
you get it done in a fraction of the time because everyone's working together.
Exactly. That's the essence of fork join.
Okay.
It's a divide and conquer strategy.
Okay.
You break down a big, complex task into smaller, more manageable subtasks
Mhm.
that can be processed in parallel by multiple processor cores.
Oh.
Then the framework elegantly combines the results.
So if I'm a developer facing a task that could take hours to process with
Yeah.
fork join,
Mm.
I can leverage the power of my multi-core processor to potentially cut that time down significantly.
Precisely. It's like going from a horse-drawn carriage to a high-speed train.
Wow.
Your data is traveling the same distance, but the journey is exponentially faster.
Okay,
Yeah.
that's a game changer.
Right.
Now let's talk about CompletableFuture.
Okay.
It sounds a bit, well, complex.
Don't let the name scare you.
Okay,
Think of it this way.
right.
You're ordering takeout online.
Okay,
In the old days,
Yeah.
you'd place your order,
right.
and then your entire browser would be held hostage until the restaurant confirmed it.
And heaven forbid you try to browse for anything else while you wait.
Exactly.
Yeah.
But CompletableFuture is like the modern online ordering experience.
Okay.
You place your order,
Yeah.
and while the restaurant is prepping your food,
Mm-hmm.
you're free to continue browsing,
Right.
adding more items to your cart or reading reviews.
So with CompletableFuture,
Yeah.
my program can delegate a task
Right?
and move on to other things
Mm-hmm.
without getting stuck waiting for a response.
You got it. It's about writing smoother, more efficient asynchronous code.
Okay.
Your program doesn't have to wait for each task to finish before moving on to the next one.
Okay, that makes a lot of sense.
Yeah.
Now on to ExecutorService.
Right.
It sounds a bit like something a tech CEO would brag about on a conference call.
Maybe.
Yeah. But the concept is actually pretty straightforward.
Okay.
Imagine a busy restaurant kitchen.
Okay.
Instead of hiring a brand new cook every time a new order comes in,
Mhm.
you have a skilled team of cooks ready to jump into action.
Right.
That team is your thread pool.
So instead of creating a new thread every time a task needs to be done,
Yeah.
which can be resource heavy,
Yes.
ExecutorService maintains a pool of ready-to-go threads.
You got it. This way, tasks can be assigned to available threads immediately,
Okay.
making your programs much more efficient.
It's like having a well-oiled machine instead of constantly building new ones from scratch.
Exactly.
This is making me want to rewrite all my code.
And we're just getting started. Up next, parallel streams. Prepare to have your mind blown.
All right, parallel streams. I'm picturing streams of data flowing in parallel, like some kind of high-tech river.
It's a great visual.
Am I close?
Imagine this. You have a massive library with thousands of books,
Okay.
and you need to find a specific quote.
Searching one book at a time would take forever.
That's my nightmare.
Right.
Yeah.
But with parallel streams, it's like having a team of super speed readers, each scanning a different section of the library simultaneously.
Oh, wow.
The search happens in parallel, making the entire process significantly faster.
So instead of processing data sequentially, one element at a time,
Right.
parallel streams break down the data and process it concurrently.
Exactly.
Right.
They're like those grocery store lines where they open a new register and suddenly everyone gets to move faster.
Much better for my blood pressure.
Right.
So for tasks involving large data sets like filtering, mapping, or reducing
Yeah.
parallel streams are a must-have.
Absolutely.
Okay.
They leverage the power of multi-core processors to drastically reduce processing time.
Okay.
And speaking of powerful processors, you mentioned virtual threads earlier.
Oh, yeah, those sounded pretty revolutionary.
They really are.
Yeah.
Think of it this way. Traditional threads are like big, comfy tour buses.
Okay.
They can carry a lot of passengers' data, but they take up a lot of space and resources.
So not the most fuel-efficient way to travel.
Precisely.
Yeah.
Virtual threads, on the other hand, are like those sleek electric scooters.
Okay.
They're lightweight, nimble, and incredibly efficient.
So I can zip around my data without any of the overhead.
Exactly.
Wow.
Java manages these virtual threads in a way that's far less resource intensive,
Okay.
meaning you can potentially create millions of them without crashing your system.
Millions.
Yeah.
That's insane.
It's a lot.
That's also incredibly cool.
It opens up a whole new world for handling massive concurrency.
Wow.
But we'll save those details for our dedicated virtual threads deep dive.
Can't wait for that one. Okay. Shifting gears a bit, what about synchronized and concurrent collections?
Okay.
That sounds like a recipe for disaster, like mixing up your baking ingredients.
It's more about keeping your ingredients organized.
Okay.
Remember how we talked about the importance of thread safety? Ensuring that multiple threads can access shared data without causing chaos.
Right, like making sure two cooks don't try to grab the same spatula at the same time.
Exactly.
Okay.
Synchronized collections are like having a designated spot for each ingredient and only one cook can access it at a time.
Okay.
It keeps things orderly,
Right.
but it can also create a bottleneck if you have a lot of cooks waiting their turn.
So what's the alternative?
Concurrent collections.
Okay.
They offer more flexibility.
Okay.
Imagine dividing your kitchen into different workstations,
Ah.
each with its own set of ingredients and tools.
Okay.
Multiple cooks can work simultaneously without stepping on each other's toes.
That makes sense. So concurrent collections allow for more fine-grained control over data access,
Yes.
minimizing bottlenecks and improving performance.
Precisely. It's like having a well-organized kitchen where everyone knows where things are
Right.
and can work efficiently without getting in each other's way.
I'm starting to appreciate the complexity of managing concurrency in Java. It's like conducting a symphony, making sure all the instruments are playing in harmony.
A perfect analogy. Speaking of keeping things organized, let's talk about ThreadLocal variables.
Okay.
Think of them like personal toolboxes for each of your threads.
Okay, I'm intrigued.
Okay.
Tell me more.
Imagine a workshop where each craftsman needs their own set of specialized tools.
Okay.
Sharing tools would be chaotic and inefficient.
Right.
ThreadLocal variables ensure that each thread has its own isolated copy of a variable, like a personal toolbox they can access without interfering with others.
So no more accidental hammer swapping between threads.
Exactly. This is crucial for things like database connections, where each thread needs its own separate instance to avoid conflicts and ensure data integrity.
Okay, that makes a lot of sense.
Yeah.
It's all about keeping those threads organized and working in harmony. What's next in our concurrency toolbox? So we've covered some really cool tools already.
Let's have.
But I know there's even more to this concurrency toolbox, right?
Oh, yeah, there's definitely more.
Yeah.
Get ready for some advanced thread choreography.
Ooh, okay.
We're going to talk about phaser, cyclic barrier, and countdown latch.
Okay.
These tools are all about making sure your threads work together in perfect sync.
So it's like we're teaching our threads how to do a synchronized swimming routine or something.
That's a great way to put it.
Okay.
Imagine a relay race.
Okay.
Each runner has their own leg to run,
Right.
but they need to pass the baton at the right time for the team to succeed.
Right.
That's what these tools do for your threads.
So it's about coordinating their actions to achieve a common goal.
Exactly. Let's start with countdown latch.
Okay.
Think of it as a starting gate.
Okay.
Imagine a group of runners all lined up waiting for the starting pistol. The countdown latch is like that starting gate.
Okay.
It prevents any thread from proceeding until a predetermined number of signals have been given.
So it's like saying, okay, everyone hold your horses until we've got all the green lights.
Precisely.
Right.
It's really useful when you need to make sure a certain number of tasks have been completed
Right.
before moving on to the next stage of your program.
Makes perfect sense.
Yeah.
Now, what about cyclic barrier?
Okay.
Does it involve tiny bicycles for my threads?
No bicycles.
Okay.
But it does involve a bit of a rendezvous point.
Okay.
Imagine a group of friends hiking together.
Okay.
They might spread out while they're walking,
Mm-hmm.
but they agree to meet at a certain landmark before continuing on.
Right.
That landmark is your cyclic barrier.
So all threads can be doing their own thing, but once they hit the cyclic barrier, they wait for each other to catch up.
Exactly. It's like saying, okay, everyone regroup here and then we'll move on together.
Okay.
And unlike countdown latch, cyclic barrier can be used multiple times,
Okay.
making it perfect for tasks that involve repeated synchronization points.
Like a reusable meeting point for threads that love teamwork.
Exactly.
Okay.
Yeah.
And finally, tell me about phaser.
Okay.
It sounds almost mysterious.
Phaser is the most sophisticated synchronization tool in Java.
Okay.
Think of it like conducting an orchestra.
Right.
Each musician has their own part to play,
Right.
and they might start and stop at different times,
Right.
but the conductor keeps everything in sync.
Right. Yeah.
That's what phaser does.
So phaser gives you that fine-grained control over a group of threads, even if they have different roles and timelines.
Exactly. It's like saying, okay, string section, you come in on measure 32, and brass section, you join in on measure 64.
Wow.
It allows for incredibly dynamic thread coordination,
Of course.
making it perfect for complex multi-stage processes.
Wow, that's impressive.
It's pretty cool.
Seems like Java really gives you all the tools you need to manage concurrency effectively.
Absolutely. From dividing tasks efficiently with fork join to orchestrating complex thread interactions with phaser,
Right.
Java empowers developers to write incredibly powerful, responsive, and scalable applications.
This deep dive has been amazing. We've gone from the basics of what concurrency is to exploring these incredible tools that Java offers.
It's a lot to cover.
I'm feeling a little more confident in my understanding of how software can handle so many things at once.
And remember, this is just the tip of the iceberg.
Oh, wow.
As you dive deeper into the world of Java concurrency, you'll uncover even more powerful techniques and best practices.
So to our listeners, if you've ever marveled at how websites handle millions of users or how your phone switches between apps seamlessly,
Right.
now you have a glimpse into the magic of Java concurrency. It's a fascinating world of parallel processing, synchronized threads, and powerful tools that make our digital lives smoother and more efficient.
For sure.
Thanks for joining us on this deep dive.